What if the greatest inventions were not built to change the world, but to reveal the parts of it we were never meant to see? Across the last century, scattered researchers, inventors, doctors, and engineers have tried to measure what normally escapes human perception. Light around living tissue, voices inside static, weight at the instant of death, signals that seem to come from beyond ordinary space. Dreams translated into images, emotions imprinted on rooms. Some of these experiments were real. Some remain disputed. Others survive as fragments of testimony, lost notes, and stories passed between believers and skeptics. But together, they form a single pattern. Human beings have never been satisfied with the visible world. Each device began with a simple question. Can life be photographed? Can consciousness be detected? Can death leave a measurable trace? Can memory, emotion, or presence exist outside the body? The answers were never clean. Scientists challenged the claims. Evidence was incomplete. Some results could be explained by physics, psychology, or error. Yet the questions refused to disappear. This is not a story about proving the impossible. It is a story about the machines people built when ordinary explanations felt too small. And it begins with a flash of light on a photographic plate. In 1939, Semyon Kirlian and his wife Valentina noticed something strange while working with high-frequency electrical equipment. When an object was placed on photographic film and exposed to a strong electric field, it appeared surrounded by a glowing outline. Fingertips, leaves, insects, and small living samples produced bright, branching halos. To the Kirlians, this looked like more than electricity. They believed they were capturing a hidden energy field connected to life itself. The glow seemed to change depending on the condition of the subject. Healthy fingers appeared sharp and radiant. Stressed or sick subjects produced weaker, broken patterns. The most famous claim involved a torn leaf. Even when part of the leaf was removed, the photograph seemed to show the missing portion as a faint outline. This became known as the phantom leaf effect. Mainstream science offered a different explanation. The images were likely caused by corona discharge, shaped by moisture, pressure, voltage, and surrounding air. The glow was real, but not necessarily mystical. Still, the Kirlian camera became famous because it gave people something they had always wanted, a visible image of vitality. Whether it revealed a living aura or simply turned electricity into beauty, the device asked one lasting question. If life leaves a trace of light, how much of us remains invisible? Nikola Tesla spent his life working with invisible forces: electricity, frequency, resonance, wireless energy. These were not fantasies to him. They were real structures hidden inside nature, waiting to be understood. That is why later legends about Tesla often place him near the border between science and mystery. One of the strangest stories describes a device called the consciousness lens. According to the legend, it was designed to detect not thought itself, but the presence of awareness. The lens was said to combine crystals, metals, and electromagnetic fields. It supposedly created a zone of resonance where Tesla believed consciousness might leave a detectable disturbance. There is no accepted proof that such a device worked, or even that it existed exactly as described. But the idea became powerful because it matched Tesla's larger vision of reality, a universe made of vibrations, signals, and hidden communication. The story claims Tesla saw a faint shape within the field, something like a presence without a body. Whether this was an observation, exhaustion, or later myth is impossible to know. But the question behind it remains serious. Is consciousness produced only by the brain, or does the brain receive and organize something larger? Tesla's supposed lens may belong more to legend than laboratory history, yet it captures a real human desire to know whether awareness is matter, signal, or something still unnamed. In 1901, Dr. Duncan MacDougall tried to measure the soul. Inside a Massachusetts hospital, he placed dying patients on a specially built scale. His goal was direct and unusual: to see whether the body lost measurable weight at the moment of death. The result became famous. MacDougall claimed that one patient lost 21 grams as life ended. He repeated the experiment several times and believed he had observed a sudden, unexplained drop in weight. The public was fascinated. Newspapers called it evidence that the soul had mass. Scientists were far more cautious. The sample size was too small. The timing of death was difficult to define. Changes in breath, body fluids, heat, and movement could all affect the measurement. MacDougall's conclusion was never accepted as proof. Yet the experiment remained unforgettable because it turned an ancient question into a physical test. When someone dies, the body is still there. Is the face, the hands, the weight, the room, all remain. But the person is gone. MacDougall wanted to measure that disappearance. His scale did not prove the soul, but it exposed the gap between biology and human experience. We can describe death medically. We can chart the body's shutdown. But we still struggle to explain the feeling that something has left the room. In 1959, Swedish filmmaker Fredrik Jürgensen was recording birdsong when he heard something unexpected. On playback, beneath the natural sounds, there appeared to be a human voice. It seemed to speak his name. From there, Jürgensen began experimenting with tape recorders, radio static, and long periods of silence. The phenomenon became known as electronic voice phenomena, or EVP. Researchers and hobbyists claimed that voices could appear in noise, sometimes answering questions or speaking in recognizable tones. Some believed these were communications from the dead. Others thought they were unknown signals or psychological projections. Skeptics offered simpler explanations. The brain is built to find patterns. In static, random sound or radio interference, we may hear words because we expect words. Tape artifacts and signal bleed can also create the impression of hidden speech, but EVP remained emotionally powerful because it connected technology with grief. A recording device preserves voices after people are gone. So when a new voice seems to emerge from silence, it touches something deeply human. The question is not only whether the voices are real, it is why people keep listening. EVP stands at the edge between evidence and longing. It may be static, it may be misheard noise, or it may be a reminder that silence is never emotionally empty to those who have lost someone. Living organisms emit tiny amounts of light. This faint glow, known as ultra-weak photon emission, cannot be seen by the human eye. It requires sensitive instruments to detect. In the 20th century, German researcher Fritz Albert Popp became associated with the study of biophotons and their possible role in living systems. The basic fact is not mystical. Cells produce light through biochemical reactions. But the deeper question is whether that light carries meaningful information. Popp believed biophotons might help coordinate biological processes. He suggested that living systems may communicate not only through chemistry and electricity, but also through subtle light signals. Some researchers found the idea fascinating. Others considered the larger claims speculative. There is a difference between detecting faint light and proving that it carries consciousness, emotion, or hidden biological language. Still, the concept remains compelling. The human body is already a system of signals. The heart uses electricity. The brain uses electrical and chemical activity. Cells exchange information constantly. If light plays even a small role in this network, life may be more radiant and complex than we usually imagine. The biophoton emitter, in its most ambitious interpretation, was an attempt to read the body as light. It asked whether health, stress, and emotion might leave optical signatures. And it raised a precise question. Are we only bodies that consume light, or bodies that quietly produce it? The dimensional signal scanner belongs to a more modern kind of mystery. The story describes a research team using sensitive equipment to monitor low-frequency atmospheric and electromagnetic anomalies. Instead of ordinary noise, the scanner allegedly detected a strange signal, brief, structured, and difficult to match with any known source. The signal was said to appear as a complex waveform, almost mathematical in shape. It did not behave like standard radio interference, seismic activity, or weather-related disturbance. From there, speculation grew. Some believed it might have been a signal from another layer of reality. Others suggested equipment malfunction, environmental noise, or misinterpretation. The most important point is this: unexplained data is not the same as proof. Science often begins with anomalies, but most anomalies eventually become errors, interference, or incomplete understanding. Only a few become discoveries. Still, stories like this survive because they reflect a real truth about modern physics. The universe is not simple. Space, time, fields, and particles behave in ways that often challenge common sense. Hidden dimensions may exist in theory, even if we have no direct access to them. The scanner's alleged signal may have been nothing more than noise, but it represents a powerful idea. If another reality touched ours for even a moment, we might not recognize it as a message. We might only see a pattern we cannot explain. In the 1990s, Canadian neuroscientist Michael Persinger became known for a device popularly called the God helmet. The helmet used weak magnetic fields directed near the temporal lobes, areas of the brain linked to memory, emotion, and spatial awareness. Some participants reported a powerful sensation that someone else was in the room. They did not simply imagine a figure. Many described a clear presence, silent, close, and emotionally charged. Persinger believed these experiences could reveal how the brain creates spiritual or mystical states. The device did not prove the existence of spirits. It suggested that certain feelings of presence might be connected to brain activity. Other researchers questioned how reliable the results were. Expectation, suggestion, and experimental conditions may have influenced the experiences. Even so, the God helmet raised a serious question. If the brain can generate a sensed presence, does that explain spiritual experience away? Or does it simply show that every human experience, including awe and transcendence, must pass through the brain? The device matters because it turned mystery inward. Instead of searching for ghosts in a room, it asked whether the room we fear most is inside the mind itself. The God helmet did not end the debate about consciousness, but it showed how thin the boundary can be between self and other, loneliness and connection, brain and belief. Dreams were once completely private. No one could see them except the dreamer. No one could record them. They vanished each morning, leaving only fragments: a face, a street, a room, a feeling that seemed important before it dissolved. Then neuroscience began to change the question. Researchers used brain scans and machine learning to connect patterns of neural activity with visual images. Volunteers looked at thousands of pictures while their brains were recorded. Later, algorithms tried to reconstruct what the subjects were seeing, and eventually, what they might be imagining or dreaming. The results were rough, blurred, and incomplete. But they showed that inner images could be partially translated into external form. This was not dream recording in the cinematic sense. The machine could not play back a perfect movie from the mind, but it suggested that the private world of dreams might one day become readable. That possibility is both fascinating and unsettling. Dreams contain memory, fear, desire, and hidden associations. They are not just pictures. They are emotional experiences. If technology can decode them, it may help science understand trauma, memory, and consciousness. But it also raises ethical questions. Should every inner image be accessible? Should the sleeping mind remain protected? The subconscious translator points toward a future where the boundary between private thought and public data may become dangerously thin. Some places seem to hold emotion: an abandoned farmhouse, a battlefield, an old hospital corridor, a room where something painful happened. Even without proof of anything supernatural, people often feel that certain spaces carry weight. The emotion field recorder was imagined as a device that could detect these traces. It would measure changes in electromagnetic fields, low-frequency vibration, and environmental patterns linked to intense human emotion. The central idea was simple: Perhaps powerful emotional events leave an imprint on physical spaces. There is no accepted scientific proof that sorrow, fear, or trauma can be recorded in walls. But the idea remains compelling because places clearly affect us. Architecture changes mood. Darkness, sound, temperature, and silence change the body. Knowledge changes perception. Once we know something terrible happened in a room, the room no longer feels neutral. The emotion field recorder turns that human sensitivity into a machine. It asks whether memory belongs only to people or whether places also store fragments of what occurred there. The answer may not require ghosts. History itself can haunt. A building can carry meaning because people remember it, tell stories about it, and react to it across generations. The device may be speculative, but the experience is real enough. We do not move through empty spaces. We move through layers of memory, and sometimes the past feels almost physical. The cross-reality oscillator is one of the boldest ideas in the collection. It was described as a machine designed to create overlapping electromagnetic fields and resonant patterns strong enough to disturb the structure of reality itself. Not a portal in a fantasy sense, but a zone where ordinary boundaries might briefly become unstable. Stories about the device include strange effects, unusual particle behavior, gravitational drift, objects moving without clear cause, and witnesses experiencing memory disturbances or doubled perception. There is no verified evidence that such a machine ever opened another reality. Claims like this require extraordinary proof, and the available accounts remain speculative. But the idea connects to real questions in theoretical physics. Modern science already tells us that reality is stranger than everyday experience. Matter is not solid in the way it appears. Space and time are flexible under extreme conditions. Some theories suggest hidden dimensions or parallel possibilities, though not in the simple way popular culture imagines. The oscillator matters as a symbol of scientific ambition pushed to its limit. It asks whether reality is fixed, or whether it has layers we do not normally touch. Most likely such stories mix theory, imagination, and rumor, but they survive because they express a deep curiosity. If the universe has seams, what would happen if we found one? And would we recognize discovery before fear closed the door? When these inventions are placed side by side, one pattern becomes clear. Each begins with an attempt to extend human perception. The Kirlian camera tried to photograph life. MacDougall's scale tried to weigh death. EVP recorders searched for voices in silence. Biophoton research looked for faint light inside living systems. The God helmet explored presence inside the brain. Dream translation tried to make the private mind visible. Other devices imagined signals, emotions, or realities beyond ordinary measurement. Some claims are stronger than others. Some have scientific foundations. Others are highly speculative. A few may be misunderstandings shaped by hope, fear, or incomplete data. But the shared impulse is real. People build these devices because the ordinary senses are limited. We cannot see radio waves, bacteria, radiation, or magnetic fields without instruments. Many invisible things became accepted only after technology made them measurable. At the same time, not every invisible claim becomes truth. Careful evidence matters. Without it, mystery becomes fantasy. That tension is the heart of the story. Wonder pushes people to ask new questions. Skepticism keeps those questions honest. The machines may not have revealed hidden worlds as dramatically as some believed, but they reveal something important about us. We keep searching for proof that consciousness, memory, death, and emotion are not as simple as they appear. The unseen world demands both curiosity and caution. History shows that many real forces were once invisible. Germs, X-rays, radio waves, and electricity all existed before humans could detect them. Instruments expanded reality by giving the invisible a measurable form. But history also shows the danger of believing too quickly. Humans are pattern-seeking beings. We hear words in noise. We see faces in shadows. We connect unrelated events because meaning feels better than randomness. That is why these stories must be handled carefully. Claims about souls, spirits, dreams, and hidden dimensions touch deep human emotions. They can comfort people, but they can also mislead them. A machine that claims to contact the dead or read the mind should never be accepted without serious evidence. The best approach is not ridicule. It is disciplined wonder. We can ask bold questions without pretending we already know the answers. We can respect mystery without turning it into certainty. We can study strange experiences without exploiting grief or belief. The most valuable lesson from these inventions may not be that they proved the unseen. It may be that they show how badly we want the unseen to be real. That desire is not foolish. It is human. But truth deserves patience, and mystery deserves honesty. In the end, these machines tell one story. A camera sees light around living things. A scale searches for the weight of departure. A recorder listens to static. A helmet creates the feeling of presence. A dream machine reaches into sleep. Other devices look for hidden signals, emotional traces, or cracks in reality. Some were based on real research. Some were exaggerated by legend. Some remain doubtful. But all of them point toward the same human question. Is the visible world all there is? We do not know. Science has answered many mysteries, but it has not answered every human experience. Consciousness remains difficult to explain. Death remains emotionally mysterious. Dreams still feel larger than their biology. Memory, grief, and presence still shape our lives in ways that cannot be fully captured by simple measurement. That does not mean every strange claim is true. It means the search continues. The most important thing is not to abandon reason and not to abandon wonder. We need both. Reason protects us from illusion. Wonder keeps us from becoming blind to possibility. These inventions may not have opened the hidden world, but they reveal the part of us that keeps reaching toward it. We are creatures who measure, doubt, imagine, and remember. We build machines not only to control nature, but to ask whether nature is deeper than we thought. And perhaps the final mystery is not what the machines saw. It is why we needed them to look.